Welcome everyone. Good morning, good afternoon. So here we are again to talk about OWASP. So if you missed part one, well, this is part two. In part one, we talked about everything related to data and protection against data abuse in APIs. And in this part two, we're going to focus more on everything authentication, authorization. And yes, there's tons of breaches. We know that. And the authentication and authorization we're going to talk about today, combined with rate limiting problems, are really at the root of many different problems. Probably the top, the top ones that we see in API Security.io and other sources for API security. So it is very critical to understand how you're going to authenticate, how you're going to protect your APIs from unwanted access or abused access related to trying to get access to information and to parts of your API that should actually be closed unless you're actually authorizing to do that. And it's touching a lot of people. Some of the problems that are some of the companies that I'm showing now on the screen have been touched by some of those authentication and authorization issues. We'll talk about Facebook, we'll talk about Instagram, we'll talk a bit about Starbucks and some others. So in the top 10, which ones are related to authorization and authentication? Well, it's basically API 1, 2, 4, and 5. So you can see it's like the top 4 out of the top 5 within the top 10. And we left apart something which is kind of unrelated, if we want, to data and to authentication, but is transversal to everything, which is logging and monitoring. So we'll talk about that today as well. So let's start with API 1. So in the OWASP top 10, this has been called BOLA, Broken Object Level Access, right? And you may have heard about this as IDOR. There's a bit of debate out there whether IDOR, why this was renamed. It's a very well-known problem. And the motivation of the team who actually worked on the OWASP top 10 when they looked at the naming was to stress the fact that this is actually an authorization problem. It's not only an ID problem, and we'll talk about this in a minute. It's at the core, it's an authorization problem. So many companies have fallen out of this. It's not the, it's not the top one for any reason. It's the top one because it's the #1 problem. And so let's see, a typical problem. So the one I've chosen today, you may have heard me explain that before if you came for like the overall API breaches webinar, it is Uber, right? So why is this an API 1 and a BOLA problem? And actually, this example illustrates why it's not only maybe an ID and a problem and an abuse of weak IDs, as we'll see. At the root of the problem, there is an API which allows within Uber, which is being called from their mobile application, to go and get the profile of any, driver, user, partner, etc. Okay. In order to access that, you need some kind of token. Now, what the hacker has been doing, this is white hacking, this was a bug bounty. What the hacker has been doing is knowing phone numbers, and only that, it was able to first trick the API to give back an error message, which is the one you see now on the screen that says message driver 47D, etc., right? And once he had that, then he was able to invoke other parts of the API that were taking that UID as a parameter, right? As you can see, this is a UID. This is not a 1, 2, 3, right? It's a really unique ID, which is a very complex one. It's 36 characters long. It's not something you can guess. However, the main core issue was here that once you knew that UID, and this is a combination of what we talked last week about, of leaking data, So this is like tricking the API into leaking some information it should not leak. It turns out it leaks this UID of the resource that I should really not know about directly. And using that in other parts of the API, although I am not the owner of the account attached to that UID, right? So I'm Isabel. I was able to trick the system in putting the phone number from Christine, and Christine is an Uber driver, right, by night. And she basically, it's not true, by the way, right? Just joking. But I have her phone number. I put her in here. This profile, pops up with her UID, and now I can go with that UID, another part of the APIs, and see her full profile, although I am not Christine, right? So that's the core of the problem. So what is really, really important for you to understand that this, BOLA problem is an authorization problem. It's first and foremost an authorization problem. And the reason mostly this is probably top one now is because we have lost again my dearest controller layer. You're probably tired of hearing me saying that now, but what we used to have on the server side, that was this controller layer that would make sure of all this kind of controls by definition. So when we're receiving a call to do something, we would verify that this information which was requested by that specific user was actually something that we could actually do or not. Much of those validation now, because of the very nature of APIs, that controller layer has disappeared. We kind of, it's gone in the ether, and instead we're doing a lot of what that controller layer was doing back on the client side, right? So what happens here is we have lost that fine granularization if we had it, or we have not implemented that altogether. So it is not an easy problem. It's not something which is easy to do, which is why this is such a wide problem. And more importantly, it's not something which is easy to do after the fact. So if you have blended in your logic all those authorization validations, then that's cool. If you don't have that today and you already have APIs and you want to put those controls on top of that, it's more complicated, right, to do than starting from a ready state, I would say. Now, the IDs problem, which is what you see in here, actually make this much worse, because if you're using as IDs something like 123, 1234, 1235, which are very guessable IDs and things that a hacker can enumerate, then it makes that problem even worse, right? Because if you have an authorization problem, and as a hacker, I can call an API and start enumerating IDs like crazy, and you don't validate that I'm actually the owner of those IDs, obviously this is like amplifying the problem to a very large degree, which is why, one of the mitigations, it's not a fix, but it will make things better in terms of exploitation, is actually to use a UID as Uber did. So instead of using 123, you're using this 36 characters long UID instead. And frankly, that would help a lot, because a lot of people, what they have done is expose directly through their APIs internal IDs, which are the ones that come probably directly from their database, from some automated increment on a database. Like every time we create a new record, then we have a new primary key, and that primary key is basically a +1. It's a counter, right? So all our resources have this, very simple number attached to it. And it's not a complicated number because we let the database decide that for us. And that's very, very common, right? So one of the solutions here is really to approaches, right? It's to make sure that those simple backend IDs never make it all the way back to the client, but instead somewhere on the way, we're going to replace that with much less guessable IDs, right? So that's one approach. Another one is whenever you want to obtain the information about somebody, so say I'm, again, back to my phone number or Uber, information, I should just be able to call Like if I'm an Uber driver, I should be able to call something like, whatever, slash driver details slash me, not with the ID. I don't care about my ID. I should just say, I want my details and my profile, and that's it, right? So there is no door here for abuse because you don't have any ID to start with in the URL itself, okay? Now, a great, source of confusion here is what is the role of OAuth in all this? Isn't OAuth what helps me with authorization and APIs? Well, in that case, no. The reason is that OAuth scopes, which are basically, the scopes you can put and say, well, that this operation has the scope, whatever, read write, and that operation has the scope, delete, or whatever the names you want to give it. Those are at the operation level. But here we're, further than that. If I'm looking at that sample on the screen again, my API slash phone, right? If I have the proper scope to call that operation, I'm good, right? Then if behind that there is a resource number that is being given as part of that URL, that is beyond what the scopes of auth allow me to control. So this is really not a coarse grain type control here. It's really fine grain control. That's why you need something totally different to actually do that. So now, how do you protect yourself from this is also by testing. So I'm talking to a lot of customers, and it's not something which is very common in terms of being tested. So we're not, as part of our testing, trying to see if an API that takes an ID, whatever it is, what happens if I put the ID of somebody else? What happens if I enumerate, right? So that's obviously something you have to test and make sure whenever you have some IDs in there, you're actually testing this in one way or another, right? And of course, one way also to mitigate, although I know I'm saying it's like after the fact here, it's like, okay, we are leaving the problem, but what do we do? Well, basically this leaves the door wide open for data scrapping, right? Well, the minute I have an API I can call, and I can enumerate IDs, and I can call this as much as I want, then I can evade millions of records with nobody seeing everything, right? So rate limiting here is going to help you mitigate that to a point, and also probably raise some alerts. As you see a lot of rate limiting events popping up all the time, it's going to be, oh, well, what's going on here? Why do I have this thing that pops up all the time in a specific operation? It will allow you to detect that condition, most likely, right? So now, what are we doing about this? So I'm going to have to reserve what we're doing about this for a later webinar. We're working on something really nice around this to help you with this. Right now, what we can do from a runtime perspective is basically to integrate with a fine-grained authorization system. So basically act as a policy enforcement point, talk to something, like an OPA engine or any kind of authorization system, passing some information we have from the request, and then enforce the fact that you can go in or not. That's easy, right? Now, what we would like to do on top of that is see how we can, let's say at this IDs level, do this virtualization of IDs for you, right? So when there is a backend API that exposes an ID, which is potentially something that can be enumerated, replace that by something that cannot be enumerated on the fly, right? So that you don't have to touch your code. We will actually do that for you. So that's something. Well, we're there. We can actually show that to you if you are interested. I can do a demo to you guys, but it's not ready to show that to maybe the complete audience right now. And I don't want to pre-announce some stuff. We'll talk about that. But the other thing we will do as well is identify IDs, because the big problem here is if you want to test this automatically, and back to my testing, the big problem that people have today is how do I discover those issues automatically? Basically, that means, I need to know I have some IDs that, and identify those. So at the audit level, report, hey, you have some potential IDs in there, beware of, potential IDOR problems, BOLA problems. And from a testing perspective, since we generate some tests automatically from the OpenAPI file, then automatically test the API by injecting and enumerating and see how the API is actually reacting. Okay, so there's two things we're working on, and hopefully we'll have some very good news and some good thing to show to you very in the next webinar. So that's API 1. Now API 2. So this is all about authentication. Well, that's kind of logical. Broken authentication. What happens if authentication is failing? Well, basically that leaves the door open to anyone invoking our API, right? So there's a bunch of companies that had problems here. We see in API Security.io a lot of API companies that are doing IoT, which are being hit by this. Because in the IoT world, many of the devices you may all have in your house, if you can somehow get into the apps and talk to those APIs directly, you will see that none of these are, very few of these. I think there's a report like a year ago that was showing that 90% of the IoT devices had zero authentication. So if you were able to talk to it through HTTP, you could do absolutely anything with it with zero authentication, or even hard-coded like admin type things inside the applications themselves, inside the apps, because basically you say, well, this is in the house of somebody, nobody is going to go and talk to this directly. But there's been a lot of problems around that. So we're going to talk about OWASP 0, just also to show that I have a greatest respect for this company. But it's happening. Those problems, they happen to the best of us. And what happened here with OWASP 0 is actually a kind of a simple thing. And when you look at it, you say, oh, damn, but that's easy to see after the fact. So what is the problem? They're using JWTs, okay, to authenticate to their authentication API. In this authentication API, because they're using JSON Web Tokens, they have made sure, based actually on some other problems that happened about 2 years ago, they made sure that nobody could use an algorithm of none when using a JWT. So I don't know if you know that, but in JWTs, you have an algorithm, much like you can say you don't want TLS you don't want encryption on a TLS connection, which kind of defeats the purpose. But you can do that for debugging purposes, for example. Much like that, you can say you want an unsigned or signed JWT with no signature, right? That's basically what algorithm none means. And this is part of the spec, which means that any company or any library who wants to be stamped to be spec compliant has to respect the fact that you can put an algorithm of known, right? So fine, they had this problem that you actually could put a known in there. So they fixed it, but they fixed it with a case sensitive filter. So now somebody comes, instead of putting known with a small e, they put known with a big E, and then they were able to forge tokens. So what's important here to know is when you put known, what it means is, from a signature point of view, is like there's no signature, right? There's no validation whatsoever. You can put any information you want inside a jar, and it will be considered as valid because the signature validation is null. Okay, so that's how they they bypass that. So of course, how do we address that? This is one problem, right? Well, first of all, as we are discovering in IoT, but there are many others, you don't want any API out there that does not have any authentication, right? There's no reason today to not put any authentication out there. And that's something we're discovering, unfortunately, at customers, every day, is when we do those inventories and look at, and discover APIs, we realize that many of them, because there is this false sense of security for internal APIs, to say, well, it's internal and it's only used by us, so it's okay, and we'll leave it open, so we don't have to deal with, keys to manage or mutual TLS or whatever way we want to do the authentication. Even worse if we want to do auth, because then we have to deploy an IDP, etc., etc. So it makes things much simpler internally to have APIs which are totally open. But of course, that makes also things much simpler for whoever wants to attack them. Now comes the time you take that API, you forget it's not authenticated, you open it to other people, and that's where problems start. What else can go wrong here? We see a lot is access tokens. So when you use an access token, use an API key, right? Or you use an access token. If you create access tokens on the fly, but you give them a lifetime of 6 months, is basically the same thing as if you have an API key, right? So the problem of having long-lived authentication mechanisms is you augment, very much the scope and I would say the opportunity for somebody to take advantage of that token is much wider, obviously, right? So if I can steal, I find an access token somewhere on GitHub or wherever it is, and then it's hard coded somewhere. Like there's like 100,000 minimum of API keys all over GitHub. So all of these things which are valid for a long period of time are much more dangerous, right? Obviously. And so use short-lived stuff. If it's all generated by machine, you can even have a customer that has taken the approach of generating an access token at every single request. So they made it very simple. They created an SDK for their client. And that SDK is used to every time they make a new request through the API, they generate a new access token. So the lifetime of the access token is the request itself, is one transaction, and then it goes away, and then it goes away. And it's very cheap. It's a cheap thing to do, and they're doing this way. So maybe that's an extreme because of their requirements in terms of security. Maybe you don't need that, but at least don't make it maybe a week, maybe make it 5 minutes, or maybe make it 10 minutes, I don't know. And even if they're short-lived, look at their scope. If somebody steals this, what can they do with it, right? Can they access all your APIs, or they're limited to a certain part of the operation within a specific API? So make sure you ensure, for again, back to risk and sensitivity, you don't let people generate tokens and then have a token that allows them to access everything. Try to have them create multiple tokens depending on the usage that they want to do of your APIs, right? Now, if you're going to use OAuth, then use it properly. What I mean by that is there are multiple ways of using OAuth today. You have multiple grant types. Most of them, not to say all of them, except authorization code, should really not be used today in any modern application. Simply because there are problems with all of them. There's problem with client credentials, a problem with passwords. Some stuff has been there to replace basic auth, basically, so it's not more secure than basic auth. And there's tons of angles of attacks through OAuth, and the version that really works well and is recommended everywhere is authorization code with this PXE support and code state support. If you need some reference and see what are the recommendations in terms of OAuth, I really encourage you to look at this financial API profiles from OpenID, from the actual inventors, from OAuth and OIDC. They have started working this as a working group when open banking came up, and as a way to recommend how to use OAuth. If you watch some videos from Nat Sakimura, who was the person who created OAuth originally, it will tell you that OAuth is a framework, and it has created a framework that you have to learn how to use that framework. So what this financial grade profile is, the proper framework usage, if you want, for financial grade APIs, right? Which means like probably sensitive data and sensitive information. Although this has been created for banking, it really is not banking specific at all and can apply to any APIs that would manipulate sensitive information, right? Finally, JWTs, again, tons of angles of attacks on JWTs. You have to be careful what you're doing there. There's an entire RFC on how to validate JWTs. And no, validating the signature is not enough. There is much more, and we're going to see that in a minute with a demo of the platform. Of course, anything related to authentication, just put two-factor authentication in place, maybe CAPTCHA. It's much easier now to do CAPTCHA. It's less a burden on the users as well with the CAPTCHA 3. again, secure storage for credential. That means in your apps, that means in, everywhere, not just about the apps themselves. Just be careful if you're a consumer of APIs to manipulate those in a secure way. It is very, very easy to leak some keys and stuff in GitHub, because you do a push, you forgot to remove it. There's some help coming on the way from GitHub to actually do that. Well, they'll find such things for you and alert you dynamically. But you will have to be careful yourself on what you're doing. And same thing as API 1, you have to test this, right? You have to test it with all kind of combinations. Just make sure that what happens if your API is invoked with back tokens, with expired tokens, with JWTs which are not signed the way you want them, or don't contain the claims you want them to have, etc., etc. All of that is should be part of the app, integration testing of your APIs. And as always, automated. So every time you deploy the API, you run those tests again, just to make sure those problems don't sneak in. Okay. Now, what do we do about this? So the first thing we will do is, as part of the audit, we're going to flag those missing authentication schemes. We'll tell you this is an API key. I'm going to show you that in a second. This is an API key. So you're using an API key. That's probably not the best thing to do. You should use OAuth in there. We'll test automatically this at the conformance scan level, and then at runtime, which is what I'm going to show you now, we'll do this JWT validation, but also make sure that if you have declared some security scheme inside your OpenAPI file, if the request does not contain that, we'll actually stop it automatically with no need for you to write any specific rule for that. Okay, so let me just get out of the presentation for a minute, and I will go to my VS Code to show you the API we're going to use for the demo. So this is my traditional Pixie as ever, which I have embellished with our security policy. So we'll talk about request limiting in a second. But I've added in here some JWT validation. So the way this works is, here I have this like embedded into the API, the OpenAPI file. I have what we call a protection, which is something we're going to engage and consume when you deploy the API. We'll consume those annotations here to say, well, whenever there is a request coming on this particular path, which is API user info, there's two things we're going to do. We'll talk about request limiting in a second. So we'll first do some request limiting, but then we'll do some JWT validation. Here I have to give the header name because it's not a standard API, so it's not using authorization. Otherwise, I wouldn't even have to do that. I've bumped up the lifetime because, as you will see, I have some manual things to do. So I gave myself a minute between the time I'm going to generate the token, I'm going to use it, so I can do it in time. And then I have this Jose header and claim pointers. Okay, so what is that? Well, if you think about it, if we look at a JWT, let's have a look at one here, right? If we look at the JWT, we'll see in the end we have a header, right? And that header is actually a JSON structure, right? And then we have some data. And again, this is a JSON structure. So the same way we said 2 weeks ago that we should enforce the structure of our API and enforce the definitions of our API, we can do exactly the same thing and apply exactly the same rules, but this time to a JSON Web Token. And now what is important here is I'm in charge, back to our positive security model, right? Rather than saying, I'm not going to accept anything that says ALG none, right? So if we put, something like this in here, which this guy is not going to be happy about, but that's okay. That's what it will look like. So you can't do this in here, right? But rather than saying, I will not accept those, I'm saying I will only accept whatever, HAS 384 in that case, right? And when the payload comes in, it needs to have certain information inside. Where is this coming from as well in terms of validation? That's back to the jailability angle, attacks that we were talking about, you could substitute information in there. You could inject some attacks like injections and scripts and stuff like this. This is just JSON that will have to be parsed and validated. So it has the same angles of validation as any other JSON structure. We probably don't want to make sure that the issuer is somebody that we actually trust. In this case, I've put jailability.io because that's what I'm using. We may have some, specific identifier that we want to validate that we use internally. We have our the date at which this has been generated, and then here, so all of these are like standard claims and contents on the JOT. And this is like specific to my company, right? So I'm Acme company, and there's some information in there that I'm transmitting that I want to make sure is there as well. If it's not there, then that's not this is not the JOT that I'm actually expecting, okay? So that means if we're going back to here, this is what the purpose of this is all about, right? Which is to, the same way I would describe my schemas in terms of the data that is required inbound and outbound, I'm going to describe the data from my Jose header, which is in here, right? And describe the data of all my claims and what it can actually contain. So what is the audience? What is the issuer? And we have jot.io in there. And this whole Acme structure, okay? So let's go and deploy this. So I have this definition here. We're going to start. So I'm going to do this live. We're going to import this API. We're going to call it live demo and import them. So as we go and import it, we'll do this audit. This is where you're going to see those errors related to security that I was talking about. Turns out this sample API I'm using is using an API key. So I get those warnings about the fact that I'm using an API key and how this can be exploited, exactly what I was telling you in terms of, long-lived API keys are more prone to problems than short-lived credentials, right? And how to fix that. So I have some of those left in here. But it's okay. Well, that's what I have. That's my API key. I've been warned. I know about it. I may want to fix it maybe later, but for now, we'll keep it this way. And then now, if I want to protect this now, I have a live endpoint that I'm talking to as part of this system. So it is deployed somewhere on the internet. What I'm going to do is generate now the protection for this API. So we're in the webinar collection. We just created our live demo. Okay, configure the protection. We'll give it a name. We'll say we're deploying this on AKS live. All right. And this is going to give me a token, right? So this is just UID. But think of this as the UID in our platform for protecting that specific API, okay? So I'm just going to copy that. And then what we'll simply do is using Helm, I'm going to deploy now, and using that token we just created, I'm just going to deploy our firewall saying you have to protect that API, right? So it's going to be starting, close that, come back here. Now we have an active instance of this running that just got registered. Webinar 42crunch.test. Okay, that's the name. And it's going to proxy all the calls to this DS42C API. Okay, so let me just go and check which IP address I got for this, which is 52.143. Okay, let's go back here. We'll go and edit. This is not going in a public DNS, so I'll have to edit my OS file in here and replace webinar.42crunch.test. All right, by this one. So now if I go to Postman, all right, and here you can see I'm invoking webinar.42crunch.test. All right. So we'll just post a new user. If all goes well, I should get a token, right? And just to prove you that this is the real one that we just deployed, we'll set some bad requests, and we will see here that this has been rejected. Okay. All right. So now we have our firewall running. It has deployed all those protections for JWT that we have seen. Okay. So let me show you how that works now. What I have done simply, I'm going to forge a token basically using jot.io, right? And then pass it to the system to show you how it actually validates stuff, right? So the first thing I'm going to do is actually generate a new epoch here, because I had to change that value manually in there. So we'll just override the issued at in here. And then we're going to take that token we just created, and we are going to pass it to our API. All right. So remember API user info, which is where we have the JOT validation. So we'll go and send that. And what do we get? We get a forbidden. Okay. What happened here? Let's go and see. Right. So what happened here is in here, I've put algorithm 384. Right, which is a perfectly valid algorithm, right? But in my requirements, so as part of my contract, what I have described, if we look back at this file here, and we look at our Jose header definition, only HS256 is actually allowed here. All right, so all right, that means we have to go back here, and we have to correct that and use HS256 instead. So I'll have to go and generate my epoch again. All right. And put that here. All right. Control A, Control C. All right. Oh. And just replace it there. And then send that again. All right. That time it worked, right? It worked because the backend actually, the whole validation actually worked. And we have a problem on the response. That's because we sent a wrong token to that API. Don't worry about that. This is the validation on the response that we talked about 2 weeks ago. So what else we would validate here? Obviously, we would validate everything you see in here, right? So for example, we have an issuer in here. It's like, let's say we have something like forge.io instead of jwt.io, right? And if I do this again, and I validate it and send it back, Control V and send. Okay, this is going to be forbidden again, right? And this time it will be up because my lifetime has exceeded. Okay, I have to do it again. Sorry, I forgot to do that. As you can see, we validate also the expiration. And put that back there. All right, Control C and Control V before it expires. Forbidden again. Right. Oh, sorry. And here you will see, oh, that's a different thing now. That's already used. Okay. So as you see, there's a lot of stuff that we validate in here. It's like it's being actually, there's a nonce, it's being used again. So, you know, the key thing I just wanted to point here is that from an authentication perspective, you know, it's very important that you validate all those aspects within your JOTs and in general, right? And that's what we will do for you automatically, as you just seen here. I haven't written a single rule. I just described in my OpenAPI file what is the token that I'm actually expecting. So rather than leaving the door open to any kind of token coming in, I describe this JOT exactly the same way I would describe the contract and the interface of our API. Okay. Let's move on to the next one because time is ticking, which is rate limiting. All right, so that's easy. You probably understand what that means. Rate limiting and lack of resources. So there's two aspects here. There's aspect around pushing back and making sure that we don't get, you know, denial of service because somebody sends us some huge buffer overflow type problems, such things. Very large strings, a very large problem, very large pieces of info, and very large JSON structures, etc., etc. But also the rate limiting itself. So the example we're going to take here, again, it's not one I'm using quite often, which is the Facebook one, right? Which is this password reset problem. So we have this problem, which is more like an authentication problem as well, that we can reset the password through our Facebook page. That's all good. And Facebook.com has some rate limiting around that, but the beta endpoint doesn't. So what happens here is I can, as a hacker, generate basically the number of combinations. So for example, the password reset is only to do the password reset, I'm sorry, you only need this token, which is only 6 digits inside, which is nothing. That's very easy to generate and brute force. The thing is, you have to have the time to actually do that under the radar, right? So on the Facebook part, there is rate limiting. On the beta endpoint, there is no rate limiting, which basically allows the hacker to go and try all the potential combinations. And before the time limit on the password reset is expired, find the reset token and then do a takeover the account. Okay. So really, from a rate limiting point of view, that's very, very important that you protect all the authentication endpoints and others from abuse. Okay, you want to protect your entire API from abuse, but this is really even more critical on authentication, right? And you want to do some smart rate limiting. So a lot of people do rate limiting by IP, and you have to be very careful with this, because it's very, very easy to generate thousands of IPs automatically, forge IPs as well. So limiting by IP in general is not going to be sufficient. So, and the good example of that, or the bad example of that, is this Instagram password reset, where you can do 200 attempts per minute per IP, right? So it's super easy. The attacker, what he was saying is, all I have to do is go and put a credit card, any cloud service provider, have a Terraform script or some script that automatically spawns, 5,000, 10,000 machines, micro machines, very cheap ones. And for $150 in 10 minutes, I'll have the password reset and I can do takeover, right? So when you do rate limiting, make sure you do rate limiting by API key, by token, by some fingerprinting, something unique that cannot be forged or created as easily as an IP can be, okay? And again, put a short time span, because the counter example of Instagram here is 200 attempts to reset the password in 1 minute per IP. That's a lot of attempts for some function, which is a human function, not a machine function. So a human is supposed to do password reset, not a machine. So 200 is way too high at the human level, right, as opposed to a machine level. So how do we address this? Well, first of all, there's another aspect in terms of resource. I'm missing, so it's fine. So in terms of resource constraints, we haven't already talked about this. We talked about rate limiting, but you want to make sure you put constraints around the data. So that's another big problem we see in every customer. So I'm going to go back to my platform here. If I look at what our scan will actually do, one of the things we do automatically is go and invoke the API and test its limits, right? So in the audit part, we're going to ask you, hey, you tell me this is a string. What kind of string is it? Is it the short string? Is it a big string? This is a username. This is a password. So obviously, whatever, 128 characters is probably the maximum you're going to accept in there, right? Logically. So you want to put some constraints around that. And once you put the constraints, we'll go and test those constraints automatically. So the more information you put in the audit, the more tests we actually can do. And testing the limits in terms of the size of the strings of an array. That's another thing that we've put actually as critical in the audit. Is one of the few critical issues related to data that we flag in the audit. And the reason is because it's very dangerous both ways. It is very dangerous not to limit the size of array in the request, and it's very dangerous not to limit them on the response. Because on the request, it's opening the door to huge, again, overflow issues. And on the response, it's opening the door to leaking a lot of data, right? So be careful with, if you're using arrays, be careful about how you actually manage them and making sure you restrict the information that can be passed through an array, right? So we'll test all of that automatically. And from a runtime perspective, so if I'm trying to invoke, for example, this logging operation, let me just look at the body here, multiple times, 1, 2, 3, boom, okay, it's going to stop me and tell me when I can do it next. I'll have different limits on different parts of the API. So on logging, it's 3. On doing this, I think I've done 5 or 5, right? So I've done 5. So we can put some limits here by operation, which is really the granularity you're after as well when you do rate limiting, okay? All right, next. Yes, I just wanted to show out to you as a call up, API 2 and 4 together are really a lethal combination, right? Because if you have an authentication problem and you have no rate limiting over that specific operation, that opens the door to a huge type of issues and abuse around the system. So actually, a lot of the problems that are broken authentication problems are exacerbated by the fact that there is no rate limiting in there either, right? All right, next one is API 5. So this is about broken function level authorization. So this is access now to operations. So this is the big difference between API 1 and API 5. API 1 is at the resource level, so the phone number level, right? API 5 is about the access to the operation itself, okay? And we'll look today at the LIKUD voting app. What happened here? Well, somewhere inside the app for voting that has been used in by the Israeli state, they left hard-coded inside the application a URL to the admin endpoint, which was actually an open endpoint. So this is like a combination of API 2 as well. Again, as I always say, all those breaches are very, very rarely a single problem. They're a combination of multiple entries in the API top 10. And so here, what happened here now, the hacker, he got access directly to this admin API that was returning the user and passwords in clear of every single administrator of the system. Why they would do that, I have no idea. But anyway, so he got, well, admin password of all the admins. Then he could use that, and he got access to all the rest of the data and the API very easily. So potentially this could have leaked the details of 6.5 million people in Israel. It's unknown whether this was abused or not, but most likely, they don't know if it was abused or not. So yes, don't mix things like admin and non-admin in the same API. That is really not a good idea. It is very easy to discover such thing through dictionary attacks, simply because we humans are not very inventive of our names. And if we have an admin operation, very likely we're going to call it /admin/, right? So then from there, you discover that there is an admin that actually answers, and you'll be able to go to the next stage, right? So if you have some admin APIs, then lock them down to whoever are supposed to allow, get access to them. That can be mutual TLS, that can be by an IP range, right? So don't trust the client applications to sort that for you and decide if the user is an admin or not, right? Because again, we're talking straight into the API, and the client app and the UI has no role in any of this, right? We go straight into calling the API. And we're back to authorization again. So you have to have some authorization level here and make sure that only people who are allowed to access some operations are actually allowed to access some operations, right? So you want to put that in place, and again, test that this is actually working, right? Don't put in place and don't test it. Just have automated testing on any of this, just to make sure that you don't open things that you should not open. And this is where all scopes could help you, right? Because that's what they're meant to do, to just make sure that the tokens that you have allow you to access certain part of the API and not others. And you would only give a token with the proper scope if you were in whatever your IDP is saying, you're in role whatever. Otherwise, you cannot get the token to start with, right? So how do we address this? Well, pretty much is through the positive security model, because we're not going to let you in unless you have described within the API that there is some admin function that is part of the interface. If as part of the interface you have not added the admin, they will not let you go through, okay? So any unknown stuff will be blocked by default. So one of the key things we do is we block everything by default, as opposed to allow everything at default and then find after if it is something you want to let go in or not. So anything that is not described will actually not get in, right? If you have some wrong scope, you're missing scopes, at the audit level, we'll tell you that, say, hey, you have declared some scope that don't exist. On the contrary, you're using operation without any scopes. So we'll bring your attention on top of that as well. And at the scan level, one of the things we do, so if I go back here, as you will see, we're testing how the API is reacting when we're trying to invoke it with unknown verbs and unknown path and bad data types, etc., etc. All this tests we will do for you just to make sure that your API reacts properly whenever it's being called with actually the with improper data. Okay. All right. And finally, login and monitoring. So this is really critical. It goes across everything now. We want to make sure that if something happens, we have some trace of it, right? So, I've been fighting, developers for the longest time in my career to, I think, ask them to put logging and debugging and monitoring in their code, even for any type of reason. It could just be to actually know what the heck is going on in an application and be able to debug it. But from a security point of view, it is really important that you have this information so that you can detect that something is happening, right? So if you have the logs and you have the trace, you can do some analysis, you can push those logs to third-party systems that will do threat protection. There's some really cool stuff now in Splunk, in Elasticsearch, like, we have customers doing that. I'll just take our logs and send it into an Elasticsearch user behavioral system, for example, or analysis that will give you this, like, potentially abnormal behaviors on top of just the positive approach that we're taking. And then you have all that trace. So if something has happened, you can go back to the root of the problem and see that something has happened. So save your logs, keep your logs, put them all over the place. Use a SIEM if you can, so that your security team is equipped with your proper information to do some forensic analysis if something is actually happening, right? So that's kind of across the board from a security point of view. But we still see too many people that actually have no clue what's going on in their system when something is happening, right? And it could be just be, any type of a customer doing some false, it might not even be an attack, but you need to have that information just to know what's going on inside the system. And enough hammering on that, but this is really, really important across the board. All right, and what do we do about this? Well, this is not a design or development time thing. We don't look at the code, we look at the interface, so there's not much we can do there at development and testing time. But at runtime, we'll make sure we're pushing all our data into logs, as I was saying, that can be pushed then into something like an Elasticsearch. So you have monitoring of that case, where you will see everything which is going on and what things have been stopped, where the request actually came from, the latency, all the things that came in. You can see the details of each transaction. So all this information is just fed and created from our logs, and you can take advantage of that any way you want. This is Elasticsearch and Grafana, but it could be something else if you wanted to. That is not a problem. All right, and I will stop there. I've taken 5 minutes more than I wanted to, but I'll finish on just saying this a bit the same thing I said last week. Our philosophy really is to help you work on all these OWASP problems as early as possible. So we really want to equip your developers, your security teams with the right tools to make sure that you don't discover this when you're in production and after production, and you do the pen testing after production because you didn't have the time to do it before that. So that's the problem we're really trying to solve, just to make sure you can discover this early when it's much easier, less expensive from a cost point of view to actually address, right? And more importantly, maybe even automate all of that. So a lot of those problems could be avoided if we had the proper testing in place automatically in the life cycle, if we were ingrain security into the life cycle, right? So that's our philosophy. That's what we're trying to push in the market, and I hope you'll buy in our philosophy and stop now for maybe one question in the minute we have left, if any. Otherwise, I'll be happy to answer any, after this call. Thank you very much for your time.